Okay, welcome to Let's Get to the Marks. Today we're looking at a physics and maths tutor walkthrough for a AQA Chemistry A-Level Polymers pack. So this is part one. It's going to be in a two-part session, so check out the other one after. Question one, this question's about ethane-dioic acid and the ethane-dioate ion. Ethane-dioic acid reacts with propan 1,3-diol to form a polyester. Draw the repeating unit of this polyester. 2 marks. So pause the video and have a go, and then I'll go through the answers. Okay, what we need to do here is to work out what the repeat unit of the polyester is. We can just draw out the original monomers. Now this is condensation polymerization. You have two different monomers, but they have identical functional groups on either end. So ethane-dioic acid has a carboxylic acid group on each end. You can see I've drawn that here, and then in a kind of bluey green over here I'm drawing our propan 1,3-diol, which is an alcohol, and so has a hydroxyl group on carbon 1 and carbon 3. Now, what's going to happen in condensation polymerization? Well, we're going to remove a water molecule, hence the name condensation polymerization. Don't forget, you've got to remove a water molecule from either end to show it going on and on and on. It's repeating. So I'm taking away the OH from the right and an H from the left, as you can see here. However, you could remove a hydroxyl group from the left and just the H from the right, as long as you've got one O on one end. So there we go. I could do that as well, like that. That's the alternative way. So this time I'm leaving an O on the right instead of leaving an O on the left-hand side. So as long as you've removed two water molecules, with condensation polymerization, for each repeat unit, you're going to remove two water molecules, one from the middle to form the link, and then you're going to remove a water molecule from both ends, i.e. a hydroxyl group from one end and a hydrogen atom from the other end. And that's what I've done here. So you've got to draw your brackets, leave the open-ended bonds in the middle. You can see my ester link is in the middle with the COO bond with the oxygen. That's my ester link. This is a polyester. And I've made that by drawing the two monomers first and then removing the water molecule from the middle, and then a water molecule from both ends, which is by removing an OH and one H from either end. So you end up with two water molecules in total removed. And there we go. That's your repeating unit. There are other ways to draw this repeating unit. Explain why polyesters are biodegradable, but polyalkenes are not biodegradable. Pause the video, have a go. Okay, polyesters obviously undergo condensation polymerization. They have a polar carbonyl group. The carbon atom is delta positive, the oxygen is delta negative. Therefore, water molecules, which have a lone pair of electrons, they're not attracted to the oxygen like that. Over here on the right, you can see they're attracted to the delta positive carbon. So they undergo nucleophilic attack. They're quite reactive, and therefore they can biodegrade. They can be hydrolyzed by water. However, if we look at a polyalkene over here, look at it. It's completely saturated. There's no polar end, and so it's unlikely to be attacked. Therefore, we want to just explain that for our 2 marks. So condensation polymers, such as polyesters, are susceptible to attack, specifically nucleophilic attack, and so undergo hydrolysis. However, polyalkenes, polychloroethene or whatever, that's not a polyalkene, that's PVC, but polyethene does not have a polar bond and so is not susceptible to nucleophilic attack. Okay, part C. So let's zing in on this because I can't really focus. Here we go. Sodium ethanoate is used to find the concentration of solutions of potassium manganate 7 by titration. The equation for this reaction is as follows. You can see it below. A standard solution is made up by dissolving 162 micrograms of sodium dichromate, MR of 134, in water, and make up to a 250 centimeter cubed in a volumetric flask. 25 centimeter cubed of this solution and an excess of sulfuric acid are added to the conical flask. The mixture is warmed and titrated with potassium manganate 7 solution. The titration is repeated until concordant results are obtained. The mean titra is 23.85 centimeter cubed.
You're still here? It's over.